Hello, kids! Welcome to our very first episode of Olinca Science Capsule. I'm Professor Ruben Leite, and I'm here to help you understand new scientific concepts. As always, these are ordinary science facts for extraordinary kids. Today's episode is titled, How is Conventional Electricity Produced? This means you will learn all about electric turbines and conventional or traditional ways of producing electricity. Be sure to write down all the words you don't understand so you can later look them up in the dictionary. Are you ready to learn and understand science? Here we go! Most of the electricity that is produced around the world is based on a scientific invention by Michael Faraday, this guy here, in 1831. This invention is called an electric generator. You can see a simplified diagram for an electricity generator here. This is the diagram. And one of its main parts is a turbine. A turbine is a rod or cylinder, very much like the one I'm holding in my hands right now, only much larger, that rotates to produce electricity. Rotation is a type of motion that we can see in the wheels of a bike, or in the wheels of a car, in a Ferris wheel, and in a clock. For rotation to happen, it needs a special kind of energy that's called kinetic energy. That is the energy that is produced by the motion of an object. This kinetic energy needs an external source. For example, a bike is powered by a kid who's pedaling with their legs and feet. Here you can see the feet, and if it's moving, then it creates kinetic energy. On the other hand, the kinetic energy for a car comes from the combustion of gasoline or gas. So you can imagine that there's gas here and there's a combustion. So it makes the car move. In the Ferris wheel, it has a motor that supplies kinetic energy. So let's think that here is the motor. So the motor gives the Ferris wheel the kinetic energy it needs. And a clock gets its energy from a battery that's on the back of the clock. This is a battery with positive and negative poles. It's the same with electric generators. They use different kinds of kinetic energy sources. Some of them are renewable or clean energies, like the ones that you're going to choose for your project, and others are conventional or polluting energies. Renewable or clean energies can be the eolic energy that comes from the motion of the wind, solar energy that comes from the radiation of the sun, geothermal energy that comes from the heat of the Earth's core, hydroelectric energy that comes from water stored in a dam or a river. I hope you can see that this is a dam. And finally, nuclear energy that comes from atom splitting inside a reactor. This kind of energy is more difficult to understand than the other ones, so this is why you're not choosing it for your project right now. Conventional energy sources include the combustion of coal and fossil fuels like natural gas and diesel. These energy sources are highly polluting and are non-renewable. We have them in this list here. Okay? Let's take a look at how they work. But first, a quick reminder. Clean energy production is related to UN Global Goals number 7, which is affordable and clean energy, number 11, which is sustainable cities and communities, number 12, which is responsible consumption and production. And finally, number 13, climate action. A good challenge for you is to explain how they are related to this topic. So maybe you can make some questions to your teacher or to me afterwards, and start talking between your classmates and see why do you think these 4 UN goals are related to your project. Coal, natural gas, and diesel are known as fuels because when they are burned with fire, they produce a lot of heat and carbon dioxide. You can see this in this diagram. This is a coal cart, a cart with coal. This gray or black thing is coal. And you have a pipeline here. The pipeline has natural gas, and sometimes it could also have diesel in it. So these are fuels. And the heat they produce is used to make steam for a water source that causes the turbine to rotate. So we have here the fire, we have the coal or the gas, and comes from this to this pipeline, and then it's heated by fire, and it produces steam. Steam is the gas form of water. Okay. However, the carbon dioxide, that it's also a product of this reaction, here is the carbon dioxide, is made up of 1 atom of carbon and 2 atoms of oxygen. This carbon dioxide is a greenhouse effect gas. That means that whenever it gets to the atmosphere, like here in the yellow part, it blocks the sun rays from coming out from the Earth surface to the outer space, instead of going this way, like number 3, for example, or this number. Well, yeah, it's like number 3 and this other one. It bounces off the Earth's surface and goes outer space. Well, if it has a lot of carbon dioxide, it forms a layer that prevents the rays of the sun to come out of the atmosphere. So they stay inside. The effect is that there's a rise in temperature, in global temperature. This is called the global warming. So the temperature of the whole Earth is rising. It goes up, and eventually it also causes climate change. So this is the reason why fuel combustion is considered as pollution, because it produces carbon dioxide, and carbon dioxide makes the temperature of the Earth go up, and then it produces climate change eventually. So after the steam is produced here, we have a zoom here. After the steam is produced, the turbine starts rotating. Rotating. Remember the rotation that we saw with the bicycle and the car and the Ferris wheel? Well, it's the same. It has a rotation here. With the help of powerful magnets that are here. These are magnets. These black layers are magnets. So these are very powerful magnets. And with its help, electric charges, which are represented by plus signs that mean positive and minus signs that represent negative. So we have positive and negative charges, and they start moving, and they produce an electric current. The electric current is the yellow line here. And this electric current within a coiled copper wire. The coiled copper wire means that there's a wire here that makes something like this, what I'm trying to draw with a laser. Okay. And then this electric current goes out of the turbine and of the generator, and goes to the transformer, and then to electrical towers and powerhouses that distribute the electricity to our homes and schools, where we use it to charge our computers, cell phones, TVs, video games, and so much more. Now that we've finished with explanation, let's do a quick recap of what we've learned. You know now how an electric generator works, with the turbine and everything. 2. The rotation of the turbine inside an electricity or electric generator needs a kinetic energy source, And we know that there are renewable energy sources like aeolic, solar, geothermal, hydroelectric, and nuclear energies. However, we also know that there are non-renewable energy sources, such as fossil fuels and coal, that are burned to power the turbine. The combustion of these fossil fuels and coal produce carbon dioxide, that is a polluting gas that causes air temperature to rise and contributes to global warming and eventually climate change. When a turbine rotates, electric particles with positive and negative charges produce an electric current. And this electric current produces electricity that helps us charge devices such as TVs, computers, and video games. That's all for today, kids. Thank you for joining me on this scientific journey for knowledge. Remember to be kind, sharp, and ask a lot of questions. Until next time, ta-da!